Players in the National Hockey League are celebrated for their speed, strength, and especially physical toughness. More than just amazing displays of athletic ability, every action and reaction that these superstars make on the ice follows the fundamental laws of physics, specifically Newton's 3 laws of motion.
Newton's laws of motion apply whenever something is moving, whether it's in the air, whether it's on the ground.
Sir Isaac Newton definitely did not have the NHL in mind when he published his laws in 1687, but the 3 laws of motion form the very basis for how objects move and react to forces applied to them, such as 2 NHL players colliding on the open ice.
Almost everything you do in hockey involves applying a force. When players collide with each other, they're applying forces on one another.
Robert Geertz is an astrophysicist at the University of Minnesota and has been supported by the National Science Foundation. In Newton's first law of motion, objects that are at rest stay at rest, and objects in motion stay in motion at a constant speed and in the same direction, unless acted upon by a force. The first law is also known as the law of inertia.
The inertia of an object remains the same unless a force acts. So if something is at rest, it will stay at rest unless a force acts. If it's moving, it will stay in motion in a constant way unless a force acts.
Consider a hockey player simply standing on the ice. He'll continue to stand still until something like an opposing player hits him with a body check. Jim Gates is a theoretical physicist at the University of Maryland and has also been supported by the National Science Foundation.
Imagine one hockey player is actually sort of looking elsewhere, and another hockey player comes up with a check behind him. He doesn't know it's coming.
Now, consider a scenario where a hockey player is moving in a straight line and at a constant speed. According to Newton's first law, the hockey player will continue to move in that direction and speed until acted upon by another force. Again, enter the opposing player.
The hockey player may have initially been skating directly in this direction, but after checking, it goes off at an angle. He would have continued in that motion, except acted upon by an external agency, here being the checking player.
Even a hockey puck sliding across the ice follows this law.
If you watch the hockey puck moving with no one touching it, it goes in a straight line. If it was perfectly frictionless between the hockey puck and the ice, it would go on at the same speed forever.
In Newton's second law, if an object has an acceleration, that is, a change in velocity, then the net force necessary to cause this acceleration is equal to the mass of the object times the object's acceleration. This law can be written with a simple mathematic formula.
F is equal to ma. Force is equal mass times acceleration.
When 2 players collide, Newton's second law allows us to calculate what the final velocities of the 2 players will be. So, for example, a very large player striking a small player at rest will create a large velocity in the small player and maybe slow down a little bit himself.
For the smaller player to accelerate, a force must be applied to him. In this case, it's the body check from the larger player. Newton's third law of motion states that for every action there is an equal and opposite reaction, meaning that the larger player experiences a force from the smaller player pushing back on the bigger player, even if the smaller player is not trying to do so, slowing the bigger player down. Newton's third law of motion further explains that in this collision between the larger and smaller players, the combined total momentum of the 2 players remains conserved.
Even though one person is bigger than the other, it turns out remarkably that the amount of force that the big guy exerts on the little guy is exactly the same amount of force that the little guy exerts on the big guy.
Whenever one object applies a force to a second object, the second object applies the same force back to the first object. This can make checking collisions difficult, since any force applied to another player is applied back to you, something Matt Molson of the New York Islanders knows firsthand.
You see some guys that are, outweighed by maybe 30 pounds, couple inches, and they end up knocking the guy over just because of, the balance they have.
To understand the real impact of these collisions on ice, look no further than these NHL superstars and the 3 laws of Sir Isaac Newton.